Welcome to today's lesson. Today we're going to be looking at electronic configuration. So what can we say is electronic configuration? It's simply the arrangement of electrons in an atom. So electrons occupy shells, sublevels, and orbitals. But what are these? So think of an atom like a hotel. We have shells is the floors of the hotel. The sublevels is the types of room on each floor. The orbitals are buried inside each room. And of course, the electrons are people on the bed. Let me explain. So these are the energy shell, the main energy levels. We say the equivalent is the floor of the hotel. So these are the big layers around the nucleus that are labeled by numbers based on how many orbitals they have. The first shell has 1 orbital. The second one has 2 orbitals, 3 orbitals, 4 orbitals. Of course, there can be, in some cases, the 5th shell, the 6th and 7th shell. Example of an element with up to 7 shells is the uranium. The more heavy they become, the more shell they accumulate. Now we've talked about the energy level. The second one is a sub-level. We said the equivalent is the rooms on each floor. They are labeled SP, D, F, and each of them has a different shape and energy. Let's look at how they all relate. This is the first shell, the second shell, the third, and the fourth shell. First shell, then it has one level, which is the S. The second level, the second shell, which has 2 sub-levels, which is the 2S and 2P. The third one will be 3S, 3P, 3D. Fourth one will be 4S, 4P, 4D, 4F. Remember, we are following the sub-levels, which is SP, DF. Then, of course, they have maximum electron they can hold. This one is 2, this one is 8, this one is 18, this one is 32. Let me explain why it can hold this number of electrons. The S sub-level can only hold 2 electrons, meaning this one is 2, this one will be 2, this one will be 2. The second sub-level can only hold 6. 2 plus 6 to give us, this is 6, this is 10. 2 plus 6 plus 10 will give us 18. That is how we got this 18. This one can only hold the maximum of 32 electrons. This is 2, this is 6, this is 10, and this is 14. If you add all these things, you will get 32 maximum electron that they can hold. This S orbital can only hold 2 electrons. The P can only hold 6. The D can only hold 10. The F can only hold 14. So the next one we're going to look at is orbital. We've treated the shell, we've treated the sub-levels. The orbital, the equivalent is the bed in each room. This is what bears the electron. And it is said that each orbital can hold a maximum of 2 electrons, and they must be in opposite spins, which is a polar exclusion principle. So an example of where it was used: carbon, the atomic number 6. The orbitals will look like this. These are the electrons. There's 2 here, there's 2 here, there's 1 here, there's 1 here, which is a total of 6. This is the 1s, this is the 2s. So in our next lesson, we'll look at the laws. In our next lesson, we'll look at the principles. Here we'll talk more about the polar exclusion theory, the Horn's rule, the energy level order, and the mid-long rule. Guess I'll see you in the next class.